Salts contain an anion from an acid and a cation from a base. Acids and bases mix to produce salts, but not always in a neutral solution. And this has to do with the fact that they're creating salts, and those can affect the pH of the solution. So here's what happens. In general, salts that produce acidic solutions tend to contain positive ions that release protons into water. Salts that produce basic solutions contain negative ions that attract protons from water. And if you remember the definition of a Bronsted-Lowry base, or Bronsted-Lowry acid, it has to do with whether they're going to donate or accept protons. So that means that the salts are actually going to affect the solution and make it more acidic or more basic, depending on the reaction. In salt hydrolysis, the cations or anions of a dissociated salt remove hydrogen ions from or donate hydrogen ions into water. So here's kind of the general rule. If you have a strong acid, a strong base, you get a neutral solution. If you have a strong acid and a weak base, you end up with a slightly acidic solution. If you have a weak acid and a strong base, you end up with a basic solution because of the ions in the salts. What we can do here is look at the titration curve of a strong acid and strong base in red, where we see the equivalence point is at 7. It's neutral. In green, we see a weak acid and a strong base. And the strong base is being added. What we see is the equivalence point is above 7. It's actually basic. It's somewhere around 9. So this is showing that those ions are actually creating a slightly basic solution at the equivalence point. Now, a buffer is a solution of weak acid and one of its salts, or a solution of weak base and one of its salts, and what it does is cause the pH to remain relatively constant when small amounts of acid or base are added. So the buffer capacity of this buffer is the amount of acid or base that can be added to a buffer solution before significant change in pH occurs. Now, to help you see what this means, I'm going to show you a graph of just water with acid and then buffer and water with acid. So when you see the blue line, what you're seeing is pure water with drops of acid added as we go along, and the acidity gets lower and lower and lower, so we've got more acidity, the pH is getting lower and lower. When you have a buffer, the pink line, as acid is added, it doesn't actually change until a certain point. At some point, the buffer capacity is reached, and then you'll see the pH start to change.